Alright, Math 3, creating polynomial equations. So hopefully you tried this on your own, using this just to check things out. So remember, the main thing is we take each of these zeros and we turn them into factors, which is basically parentheses x, then do the opposite of what they are and just string them together. Then what we end up doing is just multiplying things together. Okay, so we can do the area model to do that, or we can do just FOIL or any other multiplication. So if we're doing the area model, something like this, so we get x squared plus 5x plus 6, and that's all multiplied by x minus 5. So I do another area model. So x and negative 5, x squared, 5x and 6. So I get x cubed, 5x squared, 6x, negative 5x squared, negative 25x, and negative 30. Combine like terms, those two would actually cancel out, wouldn't they? The positive and the negative x squared, so we'd end up with x cubed minus 25. Negative 25 plus 6 would be 19x minus 30. And there's our answer for that one. Okay, for number 2, what am I doing here? So x minus 2 times x plus 5 times x plus 3. And then we do x minus 0, or just an x. Okay. When you have the 0, you just do the x, which we'll just multiply that in at the end. So if I wanted to do just FOIL, okay, I'd go x times x, get x squared, negative 2x, positive 5x, and then negative 10. And that would be, we could then simplify, right? Negative 2x, positive 5x would give us positive 3x, and then it was minus 10, and times by x plus 3, so we get x cubed plus 3x, then 3x squared plus 9x, and negative 10x minus 30. So then we simplify like terms, and we get x cubed plus 3x squared I say where I made my mistake, I was pausing because there was an issue. We have the 3x squared, so that would be 6x squared minus x minus 30. Now all of that is still multiplied by this x, so then that would just turn everything into x to the 4th plus 6x cubed minus x squared minus 30x. And there's our answer to number 2. Alright, so let's take a look at number 3 now. So I have x plus 4 times x minus 3 times x minus 4. Okay, now I'm going to do the x plus 4 and the x minus 4 first, and then the x minus 3, because that would be x squared, and then we'd get positive 4x, negative 4x, so those would cancel each other out, so then just 4 and negative 4, so minus 16. And then multiply that, we get x cubed minus 3x squared minus 16x plus 16 times 3 would be 48. And there's number 3. So sometimes they can be fairly quick, other times not so much. Alright, now with that multiplicity, all that means is I've got x plus 3 squared. Okay, now that just means x plus 3 times x plus 3. So I just go x and 3, so x squared, 3x, and 9. So I'd get and then 0 would mean times by x. So I'd get x squared plus 6x plus 9, and all that is still multiplied by x, so which would just turn it into x cubed plus 6x squared plus 9x. And there's my answer to number 4. Now, if you recall when we're dealing with the fractions, okay, so it's like x equals negative 1/4. So we would have to times by 4 first, giving us 4x equals negative 1. Then we'd add 1. So I'd get 4x plus 1 as my factor. So basically with fractions, what it comes down to is that it's the bottom number times x, and then plus or minus, depending on what it is, the top number. And it's the opposite. So we'd end up, this is negative 3/4, this is positive 1/4. Okay, then we multiply them together. So we get 4x and 1, 4x and 3, so it'd be 16x squared, 4x, 3, 12x, so 16x squared plus 16x plus 3 times 4x minus 1. And we do that area model again. This time with 3. So 4x and negative 1. 16x squared, 16x, and 3. So the bottom one's easy. Negative 16x squared, negative 16x, negative 3, 12x, 64x squared, and 64x cubed. So then combining like terms, 64x cubed, then 64 minus 16 would be 48. So plus 48x squared. 12 minus 16 would be minus 4x minus 3. And there's number 5. So still works out. Okay, now number 6, we've got 1/5, so that would be times by 5. We have 1 equals 5x, subtract 1. So we get 5x minus 1, and that's cubed. Okay, so the first one, we do 5x minus 1, 5x minus 1, 25x squared, minus 5x minus 5x plus 1. So I get 25x squared minus 10x plus 1, and that is all still multiplied by the third 5x minus 1. Okay, so once more, 25x squared, negative 10x and 1, 5x and negative 1. So do these ones first because they're easier. We're just multiplying them out, aren't we? So we end up with 125x cubed. That would be minus 75x squared plus 15x minus 1. Alright, there's the first 6. Alright, now we got 2 more fractional ones. Okay, so I'd have 4x plus 3 times 5x plus 3 times 3x plus 2. So first off, I start with this one, then I'm going to have to do this one. Okay, so you can kind of try to shortcut it like this and go 4x and 3, 5x and 3, so 20x squared, 15x, 12x, and 9. So 20x squared, that would be 27x, and that was supposed to be 9. And then the 3x and 2, so 60x cubed, 81x squared, 27x, 40x squared, 54x, and 18. So we'd get 60x cubed. And then that would be 121 x squared. Then, let's see, 81x plus 18. And there's number 7. So pretty simple. The fractions are a little more complex, but pretty simple for the most part. And we just solve them out. So this would be 5x plus 4, 3x minus 1, and 5x minus 3. Again, I know I'm going to have to do a 2 by 2, and I know my answer will then have to do a 2 by 2 or a 2 by 3, because whatever I get in that first one will go, whatever this is, will go across here. Okay? Just trying to show you quicker ways you guys can do it. So 15x squared, 12x, negative 5x, negative 4. So 15x squared, 7x, negative 4. So 75x cubed, 35x squared, negative 20x, negative 45x squared, negative 21x, positive 12. So I get 75x cubed, negative 10x squared, negative 41x, and positive 12. Alright, so those are the more simple ones. Now we're going to deal with the radicals and the imaginaries. Okay? And remember with the radicals that we have conjugates. So if we have the plus, we also have the minus. So really, I have 4 roots, not just 2. Okay, so I'm going to end up going x plus 3 minus square root of 7, x plus 3 plus square root of 7. I do plus on both of these because these are both negative. And then it's going to be x plus 3 minus square root of 3 and x plus 3 plus square root of 3. Okay, then I just multiply them out. Okay, and these ones are troublesome just because of all that extra work, which, when we get down to it, isn't as bad because the radicals usually disappear. But still, because we have so many different pieces here, it can get annoying. So x squared, 3x, negative x root 7, 3x, 9, negative 3 root 7, x root 7, 3 root 7, and whenever we multiply 2 square roots together, we kill the square roots, so we end up with a negative 7. Those cancel, those 2 cancel. 9 minus 7 gives us a 2, so I get x squared plus 6x plus 2. Okay, then we do the other side, so x squared, 3x, negative x root 3, 3x, x root 3, 9, 3 root 3, negative 3 root 3, and the roots cancel out, so we just get negative 3. Those cancel, end up with x squared plus 6x, 9 minus 3 plus 6. So now these two are multiplied together. So the last thing I need to do is to put them together, and then that'll give us our answer. So let me clear some space. So we need to multiply those ones out, and then it'll give us what we're looking for. So a 3 by 3 here. So x squared, 6x, and 6. X squared, 6x, and 2. X to the 4th, 6x cubed, 6x squared, 6x cubed, 36x squared, 36x, 2x squared, 12x, and 12. So here's our answer, x to the 4th plus 12x cubed plus 6, 36, and 36. So that would be 42, 44. 44x squared. And then plus 48x plus 12. And there's our answer. So still the same type of steps, it's just more complex and gives us more of a headache. Okay, number 10. Doing the same exact concept here. Okay, but we need the negative versions of them. So again, whenever we have a radical root, we always have its conjugate. It's positive and it's negative. So I go x plus 3 minus 2 root 2, x plus 3 plus 2 root 2, x plus 3 plus root 2, and x plus 3 minus root 2. So basically, same exact process here. Now, if you have paid attention, you probably realize that's going to eliminate, and those two are going to eliminate. This is going to end up being negative 2. This will be 9, 3x, 3x, and x squared. Okay, so I'm going to end up with another one of these. And we've got x squared, we've got 6x, and we've got 7. Okay, if I do the other one, same idea, right? That'll cancel, those two will cancel. Because that's the way it always works. Just the way they're set up. Now, 2 times 2, or 2 times negative 2 is negative 4. Negative 4 times root 2 is 2. So that would actually be negative 8. This is 9. 3x, x squared, 3x. So I get x squared plus 6x. 9 minus 8 would be 1. And so here's what we end up with. And it looks something like this. So my answer, x to the 4th plus 12x cubed plus 44x squared plus 48x plus 7. And there's my answer to number 10. Okay, the last one. Now these ones, positive and negative, so we don't need any extras. But I just go x plus 2i, x minus 2i, x plus 3i, and x minus 3i. And we're going to have the same situation going on here, even though we're only dealing with 2 by 2's. So x and 2i, x and negative 2i, x and 3i, x and negative 3i. So x squared, 2xi, negative 2xi, and then negative 4i squared. Those cancel. So I get x squared minus 4i squared. However, I should remember that I is the square root of negative 1, so if I square it, it just is negative 1. So that's like negative 1, which negative 4 times negative 1 is x squared plus 4. Okay, same here, x squared, 3xi, negative 3xi, negative 9i squared, which that would make it a positive 9. So then we get x squared plus 9. Okay, so could use a box method one more time, or just go x to the 4th plus 4x squared plus 9x squared plus 36. And we get x to the fourth plus 13x squared plus 36. And there is our answer. Okay, just remember if we are given, if it would have been just negative I, we would have also had the positive version of it. Okay, so there we go, guys. That's basically how we create those equations from the zeros.